Namaskaram students. In chemistry in everyday life, today lesson we are going to see the following topics. What are they means? Polythene, terylene, these are all polymers. And next one, natural and synthetic rubber. The next one, biodegradable polymers. So in this lesson we are going to see only the polymers, preparation, their properties and their uses. Rest of the lesson in PPT. When a small structural unit, that is called as monomer, when joined together, it forms a very large and also high molecular mass of polymer in a long chain manner, that is called as polymer. This process is called as polymerization. That polymerization, it occurs in two ways. One is addition polymerization, another one is condensation polymerization. In addition polymerization, there is no elimination will occur. Just we are going to add the smaller units so that we get the chain growth polymerization. Addition polymerization, another name is chain growth polymerization, and condensation polymerization means here some smaller molecules will be eliminated so that we get the condensation polymerization. Another name is step growth polymerization. In addition polymerization, we already learned addition reaction. Addition reaction will undergo only the unsaturated compound, that is alkene and alkyne. Here the alkene, it undergo polymerization under a suitable condition only. Here the addition of reactive end, the one of the end is very reactive one. In that end only the chain will be growth by adding a double bond monomer. Across the double bond monomer, the reactive end will be added so that we get the chain. Then the addition polymerization, there are three different types. It is based on the reactive intermediate. There are free radical polymerization, cationic polymerization, anionic polymerization. These polymerization depends on the reactive intermediate. Free radical polymerization, when the alkenes are heated with the free radical initiator, it gives free radical polymerization. For example, styrene, it is a alkene group. It is polymerized to polystyrene when it is heated with the peroxide initiator. What peroxide we are using here means benzoyl peroxide. There are three steps in free radical polymerization. In this mechanism, first step is initiation. Initiation is initiated by with the help of benzoyl peroxide. The second step is propagation step. Third step is termination step. First step, initiation, the benzoyl peroxide. Here we get the phenyl free radical along with the 2 moles of carbon dioxide. We get 2 phenyl free radical and then 2 carbon dioxide in the initiation of the free radical polymerization. The next propagation step, the phenyl free radical, it is attack the styrene. What is styrene here means ethylene formula, and we know very well CH2 double bond CH2. One of the hydrogen is replaced with the C6H5, that is called as styrene. When the phenyl free radical, it is added with the styrene, we get the stabilized radical. In the stabilized radical, see the formula C6H5 bond with the CH2 bond CH C6H5. The carbon becomes radical. One electron is one dot is given norma, that is called as free radical. That now stabilized radical, now it attack the another monomer styrene and it form the growing chain. Again the growing chain is added with many units, several thousands of monomer units. We get the polymer chain. Now the third step, termination step, the polymer chain, it can be stopped by three processes. The first one, stopping the supply of monomer, that is styrene, and second one, by coupling two chains. The polymer chain, so many polymer chain is there. If you added the polymer chain, two polymer chain if you added means the chain process will be stopped. Or another third method is if you add impurity oxygen means that polymerization reaction will be stopped. So that in termination step we follow three methods to stop the polymerization reaction. Here two polymer chain is added so that the chain reaction will be stopped.
When ethane undergo polymerization, it gives polythene. So polythene is a addition polymer of ethene. We can say the polythene as a polyethylene also, because ethane common name is ethylene. So ethylene undergo polymerization, it gives polyethylene. Both the one are same. Polythene and polyethylene, both the one same. Now there are two types in polyethylene. One is high HDPE, another one LDPE, low density polyethylene, high density polyethylene. First of all, low density polyethylene, it is prepared when the ethylene is heated 200 degrees Celsius to 300 degrees Celsius under 1000 atmosphere and oxygen as a catalyst. In this reaction, it is follow the free radical mechanism. The free radical, what is the free radical used here means peroxide. That peroxide, it is formed with the help of oxygen. Now that's a low density polyethylene, it is used as a insulation for the cables, making toys, etc. High density polyethylene, it is prepared with the help of ethylene. It undergo polymerization in 373 Kelvin and 6 to 7 atmosphere pressure using the Zeiser Natta catalyst. It is a mixture of tetrachlorotitanium and triethyl aluminum. This HDPE, it is used to make the bottles and pipe because it has high melting point and also high density. The next one, preparation of Teflon. Teflon means it is a polytetrafluoroethylene. When the tetrafluoroethylene, it undergo polymerization when heated with the oxygen or ammonium persulfate under high pressure, it gives Teflon. What is Teflon means? It is a polytetrafluoroethylene. Now this uses, what is the uses means? It is used as in non-stick utensil, it is used as a coating material. In non-stick utensil, what is the coating material means? The Teflon. What is Teflon? It is a polytetrafluoroethylene. Orlon, another name for Orlon is polyacrylonitrile. Simply it is called as PAN. The PAN is prepared from the vinyl cyanide. Common name for it is a common name. Another common name is acrylonitrile. Now IUPAC name for vinyl cyanide is prop-2-ene nitrile. See that the prop-2-ene nitrile, there are 3 carbon. In the second carbon double bond. In the first carbon it contains CN. CN means nitrile. So prop-2-ene nitrile. It undergo polymerization in the presence of peroxide as an initiator. On heating, it gives PAN. Usually, blanket sweaters, they are built with the help of wool. So here, instead of wool, if we use Orlon, we can make the blanket and sweater in artificially. Condensation polymerization, it is also like addition polymer, but what is the difference between these two means? Without elimination means that is called as addition polymerization. Here some simple molecules like water, ammonia we are going to eliminate, afterward we are adding means that is called as condensation polymerization. That some condition is there, each monomer should have at least 2 substitution reaction it undergo during that polymerization reaction. That is one condition. Then another condition, each monomer must at least have 2 functional group, that is called as bifunctional group. For example, nylon 6,6 is prepared by mixing equal mole of adipic acid and hexamethylene diamine. Adipic acid, see that how many carbon is there? 6 carbon, so hex and single bond, so ene, and first carbon and sixth carbon they have acid groups, so 1,6 dioic acid, that is called as adipic acid. The next one, in hexamethylene diamine there are 6 carbon, that CH2 means called as methylene, so 6 methylene group is there and 2 amine is there, so that it is hexamethylene diamine. Now IUPAC name 6 carbon means hex, single bond ane, and first carbon and sixth carbon they possess diamine, so 1,6 diamine. It is the IUPAC name for hexamethylene diamine. Now when we add these two, we are going to eliminate the water molecule. In acid it gives OH group, and in amine it gives hydrogen. So we are going to eliminate 2 moles of water molecule from the adipic acid and hexamethylene diamine. Afterward, that added unit, many times it is added means n times it is added, we get the polyhexamethylene adipamide. Here amide bond will be formed. Which is amide bond means indicated in brown color, NH bond C double bond O, that is called as amide bond. And in before that, the nylon 6,6 is formed. Before that, it formed first nylon salt. How it is formed? The nylon salt means that acid, usually acid gives H plus ion. That H plus from the acid group goes to amine, NH2, it attract the H plus, so it becomes NH3 plus. The both the side amine now becomes NH3 plus, and both the side acid it gives the H plus, so it becomes COOO minus. This minus character will attract the positive character, so this one is called as nylon salt. Afterward, the nylon salt and heating, it gives the polyhexamethylene adipamide, that is called as nylon 6,6. It is usually used in textile manufacture of cords. Nylon 6, it is obtained by caprolactam. It is a monomer. Another name for caprolactam is azipan-2,1. Azi means nitrogen. Nitrogen usually it is called as aza. Here 7-membered ring is here, so that it is called as azi, and 7-membered ring is called as pan, and second carbon we have ketone, so 2,1. IUPAC name of caprolactam is azipan-2,1. When it is on heated 533 Kelvin, it added water. The water split into HOH. The OH goes to CO, so it becomes COOH, and one of the H goes to NH, it becomes NH2. Now we get NH2 CH2 5 COOH, that is called as epsilon V amino carboric acid. IUPAC name is 6-amino hexanic acid. On heating this epsilon V amino carboric acid, it eliminate water. How we are eliminating water means, in acid it gives OH group, in amine it gives H. So we get NH CH2 5 and C double bond O. It repeated in many times. It gives nylon 6 polymers. This polymer used to tire cords, fabrics, etc. It is prepared with the help of ethylene glycol. IUPAC name is ethane 1,2 diol. Eth means 2 carbon. The 2 carbon, each carbon containing OH groups, so that 1,2 means first carbon and second carbon both the one containing OH groups, so it is called as diol. The next one, terephthalic acid. Terephthalic acid means benzene containing 2 COOH group. In first carbon and fourth carbon it contain acid groups, so that benzene 1,4 dicarboxylic acid is the IUPAC name for terephthalic acid. When ethylene glycol and terephthalic acid, it undergo polymerization when it heated 500 Kelvin in the presence of zinc acetate and antimony trioxide, we get the terylene with the elimination of water molecule. The water molecule is eliminated. The alcohol groups it gives hydrogen, but acid part it gives OH groups, so that we removed water 2 moles of water molecule. The remaining what we are having, if it joined means that unit repeated in n times, we get the terylene as a polyester. This polyester, it is used with the mixing with the cotton or fiber wool to get the polycotton, polywool. It is used as a glass reinforcing material in safety helmets. Bakelite, it is prepared from phenol and formaldehyde. When the phenol and formaldehyde, it is polymerized in the presence of acid or base as a catalyst, it gives orthohydroxyl methylphenol or parahydroxyl methylphenol. Afterward, the orthohydroxyl methylphenol, it undergo polymerization with the elimination of water. It gives a linear polymer that is called as Novolog. Again, that Novolog, it is further eating with the formaldehyde, it gives the bakelite. It is a cross-linked polymer. Bakelite is a cross-linked polymer. This bakelite, it is used in the manufacture of the glue for binding laminated wooden planks, and it is used as a varnish. Hard bakelite, they are used to prepare a comb, pens, etc. The byproduct, now Novolog, the intermediate, not byproduct, the intermediate Novolog, it is used in paints. Melamine formaldehyde polymer we get when melamine is added with formaldehyde. Formaldehyde IUPAC name is methanol. The melamine, I indicated the number 1, 2, 3, 4, 5, 6. The first carbon, it possesses NH2. That NH2, the one of the hydrogen, it goes to O of the methanol. So we get one compound. That compound, the first carbon, amine is attached with the formaldehyde. Same way, in third carbon and fifth carbon, it possesses NH2 group. That NH2 group, it gives one hydrogen with the formaldehyde. That formaldehyde now attached with the amine of the third and fifth group with the CH2OH. It is written ma. That is, if that you need, it is attached many times. N times means we get the melamine formaldehyde polymer. What is the use of this melamine formaldehyde polymer is, it is making unbreakable crackery. It is used in making unbreakable crackery. Urea formaldehyde, the formaldehyde is added with the urea. The urea underlined hydrogen, it goes to oxygen of formaldehyde, we get first compound. Again, that first compound, it is underlined another hydrogen in amine. That red hydrogen goes to O of the another formaldehyde, we get second compound. That second compound, now I underline in red color, that hydrogen of amine, it goes to oxygen of another formaldehyde. Like this, it goes on, we get a complex polymer that is called as urea formaldehyde. Copolymers means the monomer, it has different kind of monomer. Then homopolymers means they have same kind of monomer. Same kind of monomer they gives the polymer, means that is called as homopolymer. Copolymer means it contains different kind of monomer, two or more different kind of monomer linked together to give that polymer, means that is called as copolymer. For example, Buna N. In Buna N, it contains styrene is one of the monomer, and butadiene is another type of monomer. Both the one joined together gives the Buna N rubber. Another name for Buna N rubber is SBR rubber. S means styrene, B means butadiene, and R means it is rubber. The next one, natural and synthetic rubber. The rubber naturally occurring is it is a polymer. We are obtaining that rubber from the latex. The monomer unit in the natural rubber is cis isoprene. IUPAC name is 2-methyl-buta-1,3 diene. Now I indicated in structure in number, that is 4 carbon. In the second carbon we have methyl. In the first carbon and third carbon it contains double bond. So the name of this compound, this cis isoprene, is 2-methyl-buta-1,3 diene. When it undergo polymerization, it gives cis polyisoprene. It is the natural rubber. The natural rubber, it is not a strong one, and it is not as a elastic. It gives not a elastic formation. So that property we are going to modify with the process. That process name is vulcanization. Vulcanization, that is cross linking of rubber. This process is found by Charles Goodyear. He found that process accidentally when he dropped the mixture of natural rubber and sulfur on into the hot stove. He saw the rubber is a strong and also elastic. So this process now developed to bring about the soft rubber and also hard rubber. Depends on the sulfur content. There are two type of rubber. That rubber contain 1 to 3 percentage of sulfur means it is soft and stretchy. Now the sulfur contain 3 to 10 percentage of sulfur means that rubber is harder but it is a flexible one. The natural rubber, when it is mixed with 3 to 5 percentage of sulfur and it is heated in 100 to 150 degrees Celsius, we get the cross linking of cis 1,4 polyisoprene chain through the disulfide bond. This process is called as vulcanization. Let's see some preparation of synthetic rubber. The synthetic rubber we are getting from the polymerization of buta 1,3 diene and its derivatives. We get the rubber like polymer. Then first one, preparation of neoprene. The neoprene we get the polymerization of monomer 2-chloro-buta 1,3 diene. Another name for this one is chloroprene. When this chloroprene is undergo polymerization by free radical polymerization, we get the neoprene. Then it is a superior rubber and it gives the resistance to the chemical reaction. Uses of this neoprene is it is used in the manufacture of chemical container, conveyor belt, because in chemical why it is used as a chemical container means because it is resistant to the chemical reaction, so that it is used as a chemical container. Buna N rubber, it is obtained from buta 1,3-diene when it is added with vinyl cyanide. Another name is acrylonitrile. In the presence of sodium, we get Buna N rubber. Bu means butadiene, Na means sodium, N means nitrile. Now see the reaction. In buta 1,3-diene, it contains double bond in between the first carbon and second carbon and third carbon and fourth carbon. The double bond, it moves to second and third carbon, and third and fourth carbon, that pi electron moves to another vinyl cyanide, so that we get the bond between fourth carbon and then the vinyl cyanide, the first carbon, and then the vinyl cyanide also contain double bond. The double bond goes to outside, so outside we have one single bond so these unit repeated n times we get Buna N rubber. This Buna N rubber, it is used to produce the hoses and tank lines. Next one, Buna S rubber. Buna S rubber means Bu means butadiene, Na means sodium, S means styrene. Now the butadiene, buta 1,3 diene, it is indicated number with the double bond The same way in Buna N rubber also, in Buna S rubber, the electron move from first to second carbon to 2 to 3 carbon and third to fourth carbon to the first carbon of vinyl benzene, so that we get the Buna S unit. That unit repeated in n times means we get the Buna S rubber. Simply we say that wherever the double bond is present, it is changed as a single bond, and the single bond is changed as a double bond. That side chain never the side chain having single bond means it never changed as a double bond. So keep it in mind, this one. And the Buna S rubber is a both the one, the Buna N and Buna S, both the one is a copolymer. Why it is copolymer means it has two different monomer, that is buta 1,3 diene along with that vinyl cyanide in Buna N. The same way in Buna N, buta 1,3 diene, it contains vinyl benzene, another name is styrene. The ratio of this buta 1,3 diene and vinyl benzene is 3:1 in the Buna N. The substances which are readily decomposed by microorganisms, they are called as biodegradable. Natural polymers, they are degraded by microorganism, but synthetic polymers, they do not degrade by microorganism. So it is a serious problem now. It is make the entire environmental pollution, so that we have to develop the biodegradable polymer now. That biodegradable polymer, they are broken down by soil microorganism. For example, for biodegradable polymer are polyhydroxybutyrate, CoA hydroxyl valerate, polyglycolic acid, polyacetic acid, polyepsilon caprolactone. These biodegradable polymer, they are used in medicinal field, and these polymers are decomposed by enzyme action and are either by metabolized or excreted from the body. Preparation of PHPV, it is one of the biodegradable polymer. It is obtained by when 3-hydroxybutanoic acid is combined with 3-hydroxypentanoic acid. We have to remove the water indicated in blue color. The acid group gives OH and the alcohol groups H. So in 3-hydroxybutanoic acid, the third carbon gives having alcohol, it gives hydrogen, and the first carbon acid, it gives OH for removal of water. The same way in 3-hydroxybutanoic acid, the first carbon gives OH and third carbon alcohol, it gives H. It is indicated in blue color line. Now we get the ester linkage in between when we add 3-hydroxybutanoic acid and 3-hydroxypentanoic acid on removal of water, it gives ester linkage. Uses of PHPV, it is used in orthopedic devices and also in controlled release of drugs. Nylon 2, nylon 6, it is also biodegradable polymer. This one is obtained when glycine is added with amino caproic acid. It is also combined with removal of water. The acid gives OH group and amine gives hydrogen in glycine and amino gabric acid, and then we get the amide linkage when the two units joining together on the removal of water, it gives amide linkage. When the unit is repeated n time, we get the polymer, so that this one is called as polyamide linkage.